All right, I think we can proceed with the solution. Okay, so three masses are given, and in the question, there is nothing asked about any interaction between the masses. So why not just take it as a one whole block? Okay, so if I take this as one whole block, what will be the total mass? It will be 6 kgs. All right, so if I draw the FBD of this mass, this is 6. So there is an mg acting downwards. This becomes 6g. Normal is upwards. F is acting in this direction, and friction is there in this direction. All right, so I have this F minus F is going to uh, no, it just wants to starts to move. So my F will be equal to the friction, which will be equal to mu into N. And what is in the vertical direction? There is no movement. So N will be equal to 6G, that is 60. So N is 60. So my friction is, what is mu? Mu is 0.4. So that becomes 24. So F is 24. That means 24 newtons is required to move this. So F is 3T. So 3T needs to be equal to 24. So at what time will it be? It will be 8 seconds. So B is the answer. All right, someone got the answer by some other method as well. Who was it?
Yes, I did.
All
I
right.
did by
Did
the
you?
method that 3T, that's the force, minus frictional force will be equals to the mass into acceleration of the body. Like judging that it's actually moving. We are taking a hypothetical case in which the force is enough to
Okay.
move all the three blocks.
All right.
When
So
we
what did you
calculate,
take the acceleration?
no, just 6a. We have taken the final into 6 into a mass into
Okay.
acceleration. When we
Okay.
solve,
Your voice is cracking. Hello.
hello, so
Hello. Yes. 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 It's audible now.
okay, uh, okay, I'll just repeat again. 3t minus mu n equals to 6a.
All right.
When you solve that, you get hello.
Yes. Yes. It's audible. Yes.
Yeah, in the end, you get t equals to a plus t equals to a plus 8. At that time,
All right.
judging from the equation, we'll get a positive value of a only if t is more than 8. So that's why I put 8 as the answer.
Yes. That is not a different or a wrong approach. It is also right. Like it is just writing these equations in some other manner. So yes, conceptually it's the same. No difference in that. All right. Anyone else was someone else was having some doubt?
No, sir, you cleared it. I understood.
All right. Okay. Shall we move to the next one?
Yeah, sir.
Okay. A block of mass 1 kg is placed on a rough horizontal surface and it is connected by another one, like shown in the figure. Both of them are having mass of 1 kg. And this surface is having friction. Am I right? Yes, this is rough horizontal surface. So there is friction over here. With coefficient of friction mu is 0.2. Now you have to find the acceleration of the system. Will the acceleration be same for both of them? Or is it going to be different?
It will be different.
It will
Why
be,
will it be
I
different?
think it will be same because it's
Yes, it will be
one
same.
thread.
Yes, exactly. It will be same. One thread, although it is one thread and all the pulleys are at rest, like no pulleys moving. So both of the masses are going to have same accelerations. No, Jen, wrong answer. No, Arnav, wrong answer.
So the hanging one is not touching the ground, is touching the surface, is
Yes,
it?
it's not touching the ground. No, it is not
Okay.
touching.
So I made a silly mistake in the calculation.
No problem.
So
Yes,
are
that's
we
the right
supposed to
answer.
take 9.8 as B? No, it won't make a difference. Never mind.
Yes, it won't make a difference. The options are in terms of G only.
Can you explain this question?
Yeah, sure. Has everyone tried? Shall I proceed with the solution?
Yeah, sir.
All right. So the string is same. So here is T, here is also T. So let's start with making FBD for both of them. For the one on the surface, this is 1. So it is having mg downwards, that is 1g. It's having normal force upwards, tension T, and it wants to move in the left direction. So there will be friction in the right direction. Is there anything else? All right, that's all. And friction will be mu into n, and in the vertical direction there is no motion, so n will be 1g. I'll just take it 10. So n is 10, so friction will be, what is mu? Mu is 0.2 into 10 will be 5. No, just a second. It will be, it is 0.2 into 10, that is 2. So friction is 2. Now what is happening? T minus 2 is 1 into a. Suppose it is going in the left direction with a and it is coming down with acceleration a. So t minus 2 equals to a. All right. Now coming on to this block with mass 1, it is having 1g downwards and t upwards. I think that's all. So 1g, that is 10, minus t equals to a. Now here is minus t and here is plus t. So I'll just add up both of these equations. So what will I get? 8 equals to 2a. A is 4. 4 is 0.4 g. So B is the right answer. Clear to everyone?
Yeah, sir.
किसी को डाउट है? All right. A block of 10 kgs is pulled by a constant speed on a rough horizontal surface by a force. Then the coefficient of friction is. Yes, Jen, right answer. Yes or no, right answer. Shall we proceed with the solution?
Yes, sir.
Okay. So the block is being pulled by a constant speed. There is no acceleration, there is just constant speed. So that means the block is still in equilibrium with respect to the forces. All right, so the forces are the resultant force on the block is zero. So if I make FBD of this, there's nothing but this force and an mg, that is 10g, a normal reaction n, and a backwards friction f. Now this f is mu into n, which is n is 10g, so this becomes mu into 10g, that is 100. Now this force and this friction are equal in value, that is force is 19.6 over here. All right, just a second. I won't take G as 10 over here. Why will I not take G as 10? Because I'm seeing that this is a multiple of 9.8. So I'll take this as 10 into 9.8. So this mu into 10 into 9.8 is equal to what? 19.6. So mu is 19.6 upon 9.8 to 10. This is 2. So 2 upon 10 is 0.2. All right.
Sir, I took it as 10 and I got like 0.19. I rounded off to 2.
Yeah. No issues with that. All right. A body of mass m is kept stationary on a rough inclined plane of inclination theta. The magnitude of force acting on the body by the inclined plane is. No, no wrong answer. No, Jen, wrong answer.
Oh, it's a rough inclined plane.
Yes. Do you want some hints?
Yeah, so
All right. See, first of all, the question is asking me the force acting on the body by the inclined plane. So what is actually meant by that? If this is my inclined plane and this is the body kept over it. So if I make the FBD, no, I won't be making FBD right now. By the inclined plane, there is a normal force and a friction as well. So both of them are force acting on the body by the inclined plane. All right, so you will have to find the resultant of both of them.
they haven't given us the coefficient or anything.
They don't need to. Yes, they don't need to. We have been given mass m, we have been given theta, and we all know there is g also available to us. That is sufficient. Yes, sir. Now, right answer.
Sir, I'm pretty sure my method is wrong, but the answer is
Who is this speaking? Arnav?
yeah. So I'm pretty sure my method is wrong, but like my answer is right.
Oh, okay. I can understand what you must have done. Anyone else with the answer? Is someone trying, or shall I proceed with the solution?
So proceed with the solution.
All right. So let's make the FBD of this block. Suppose this is my block and this is the inclined plane with theta. So what are the forces acting over it? There is an mg downwards, normal force at an angle, and a frictional force over here. All right, so I want to analyze these forces, so I'll have to choose two axes. So I'll choose one parallel to the incline and one perpendicular to the incline. So I'll have to resolve mg. So how will I resolve mg? I will take this and this. This will be theta. So this will become mg cos theta, and this will be mg sine theta. Now this block is at rest. So I can say F is equals to mg sine theta and N equals to mg cos theta. And I want to find the total force acting on the body by the inclined plane, that is F and N. Both of them are acting 90 degrees to each other. So my total force will be resultant of both of them, that is under root of F square plus N square, that is under root of mg sine theta square plus mg cos theta square whole under root. Mg square will come outside, that will become mg, and under root of sine square theta plus cos square theta, that is equals to 1. So my answer is mg.
So never mind, my method was correct.
That's
So
great
I
then.
didn't read the question properly. I forgot to write stationary. Like I was thinking that it's moving, and I did that way, and I didn't get the answer.
Oh,
Yes, if it's kept stationary, so yes, it's mg. mg sine theta, the
yes,
frictional forces. Yeah, I
yes.
didn't see that.
And one more thing you can think of is that, like, what is the force acting on the block without the incline? It is only mg force, but it is stationary because there must be some force acting over it with the same magnitude and opposite in direction. So, who is providing that force? Only incline is providing that force. So that way also it had to be mg. All right, let's move on to the next one. A block of mass 1 kg just remains in equilibrium with the vertical wall of a cart accelerating uniformly with this acceleration. The coefficient of friction is yes, Jane, right answer. Yes or no, right answer. Shall we proceed with the solution?
Yes, sir.
All right. This is the block of mass given to us, 1 kgs. mg is acting downwards, that is 1g. Normal is acting in this direction and it wants to fall downwards, so the friction will be acting upwards. Is there anything else happening over here? No. And the resultant acceleration is 20. So what do we have? We have F that is equal to mu n. So I have mu n equals to 10 from 1g, and n is the reason for this acceleration. So n equals 2 mass into acceleration, that is 20. So I put 20 over here. That is mu into 20 equals to 10. So mu comes out to be 0.5. आगे समझ में?
Yes, sir.
All right. A block of mass 1 kg is placed on a rough incline as shown. Coefficient of friction is given. What is the acceleration of the block? Yes, Jane, right answer. Guys, this is an easy question. Shall I proceed with the solution?
1 second.
Shall we proceed with the solution?
Yes, sir.
All right. On this mass, we have mg downwards, normal upwards, and friction behind. And we want to find the acceleration. So we'll resolve mg. That will give us, this is 30 degrees. So this will give become 10 into cos 30, that is root 3 by 2. And this will become 10 into sine 30, that is 10 into 1 by 2. And there is no motion in the vertical direction, so n equals to 10 root 3 by 2, that is 5 root 3. Friction is equals to mu n. Yes or no, right answer.
Sir, I did a very silly calculation mistake. That's why I wasn't getting the answer.
All right, this is mu n, that is 0.4 into this 5 root 3. So that is 0.4 is 2 by 5 into 5 root 3, that becomes 2 root 3. What else? We want to find the acceleration. So 5 minus F equals to, what's the mass? 1 into A. F is 2 root 3. So 5 minus 2 root 3 equals to A. Root 3 is 1.7. So this will be 5 minus 3.4. So A comes out to be 1.6. All right, let's take last question for today. A block of mass 2 kg is resting over another block. Then the block below is pulled. So we want to find the force required. The force required to pull out this block with this given acceleration.
Uh, they haven't given the coefficient of friction between the block and the
There
floor.
is, there is.
Between the blocks, right? Not block
Yes,
and floor.
yes, yes. The surface is frictionless.
Oh, okay.
No, Zen, wrong also. No, Arnav, wrong answer.
So mine.
Sorry.
So even I have given the answer. Is it?
Yes, Jain and Arnav have given me wrong answers. Yes, Arnav, that's right. Shall I proceed with the solution?
Yes, sir.
Okay. So let's start by making FBTs for both of these blocks. So which one should I start with first? Let's start with the 6 kgs. All right. This is 6. This is having mg downwards, 6g, having a force F and no friction, and it is having normal by the surface. So I can call it NS, and a normal from above by the block acting below. So I can call this NB, and friction by the block above it. This block wants to move in the right, so friction will be acting in the left. All right, that's it. So there's no motion in vertical direction. So I have NS equals to NB plus 60 and F minus F. Now this F is because of the block above, so it is proportional to NB. So this can be written as mu into NB. Mu is given as 0.4. So this is 0.4 into NB, that is mass into acceleration. Acceleration is 1.5. So that comes out as F minus 0.4 NB equals to, what is 6 into 1.5? It is 9. All right, coming on to the other block, 2 kgs is having 2g downwards, NB upwards. It is applying force in left direction for the below, so it will itself experience a force in the opposite direction as an action reaction pair, and a tension in the left direction. I think that's all for this. So there's no movement in vertical, so NB equals to 20, and it is not moving in horizontal direction as well. So F equals to T. What is F? F is mu into NB, that is 0.4 NB equals to T. The question doesn't ask about tension, so we can just ignore this. What's important for us is this NB equals to 20. We'll substitute it everywhere. We'll get F minus 0.4 into 20 is 8 equals to 9. That gives us F equals to 17. A is the right answer. Right, clear to everyone? आगे सबको समझ में किसी को डाउट है?
No, sir.
All right then. That's all for today, guys.